So good evening all. This is the 8th live session related to numerical methods for engineers. So as every week we are doing the live sessions, we are conducting the numericals related to solving numerical related to the week that has been gone by. So this is a typo here. This is a week 7 it should be. So last week we didn't have any this thing online live session, so that live session was already recorded in the weeks before. So we recorded two live sessions in the week 6 and that have been uploaded on my YouTube channel. So if anybody has not got the link, just go to my YouTube channel and go saw those lecture video recordings, so you can solve your assignment is already gone, but for your exam that is coming by, you can solve those. So brief introduction about me. I am Rigved Saman, PhD student at IIT Guwahati and currently working in the lithium and battery field. I am using these techniques for my research purpose. So this the knowledge using these methods can be useful for you guys. So that's why I'm conducting this live session, but under the PMRF fellowship grant. So in the last week we completed the interpolation chapter. In interpolation we saw Newton forward difference, backward difference, divided difference, and we saw how to get to those how to calculate those using a tables, right? So interpolation means you have got some discrete data points within a continuous set and you want to find a point function value at some value between that given data set. So that is why we use interpolation. The extrapolation is also same. The methods basically are same, but we have not discussed that. We just got from regression, interpolation, and now we are into numerical differentiation. So in numerical differentiation is about this thing, right? We started with in the video lecture what is a numerical differentiation with the slope. So differentiation by definition is a dy by dx, that is a slope of the line, slope of the function at some point. So if you have, let's say, I'll use a bigger this thing. So if you have a function like this, and if you are interested in the point here, and if you want to know the numerical differentiation, you will take a slope of it, and with the help of slope, then we use a Taylor series approximation. So what are the different types? The forward difference and central difference. So how they are defined is that I will show you. So if this is the point that you are interested in, and if this is a slope that you have imagined, then you will take a certain delta x. Let's say this is the point you are interested in. You will take a certain delta x. This is x, this is y. This will be I plus 1. So draw it in a better fashion. Okay. And again this is a delta x, and again you have a delta x here which cuts at here, I minus 1. So central difference means forward difference means you will consider only these 2 points. Central difference means you will consider this and this point. So in central difference, in forward difference is delta y dy by dx becomes yi plus 1 minus y I. So this is your y value, right? So this is yi plus 1. This is your yi minus 1. This is y divided by delta x, xi plus 1 minus xi. In central difference, this is dy by dx is nothing but yi plus 1 minus yi minus 1 divided by xi plus 1 minus xi minus 1. This numerator is, if you call this a delta x, this is 2 delta x. So this is how the formulas are, and there is, we saw in the video lectures what is the error analysis. So with the further ado, we will go with the numericals so that you will get a better understanding of the how to solve them. So theory has been extensively taught in the video lectures. If you have any doubts, you post it to me. You can ask it right now. We will talk about it. So these sessions are basically for giving you an idea of how to solve the numericals. So I'm basically going to numericals directly. So first question is, consider the following function. The derivative of this function is given by this. So you have given a function f of x and f dash of x that you can call as a y and y dash. Yeah, already been given. A y dash true is been given to you. Okay, this is also true. And you are they are telling you find the numerical derivative at x is equal to 1.6 using forward difference formula and central difference formula separately. Take h is equal to 0.2. So first is use forward difference, and second he is telling you to solve it with the central difference, and in the both case h is equal to 0.2. So h is nothing but delta x is equal to 0.2, that is given to you. Okay, and what you are telling you to find out, find the numerical derivative, that is nothing but dy by dx is equal to what? Now it is telling you to forward difference. In forward difference, it is just where we will consider these 2 points only. So it is yi plus 1 minus yi divided by delta x. Now what is yi plus 1 and what is yi? For that we have been given this function. So what is a function? Y is equal to e raised to minus x sin x by 2, right? X is, it is given you 160. X is equal to 1.6. X is equal to 1.6. Therefore yi plus 1, how you will find? It is at y of 1.6 plus h, that is y of 1.8. So that is yi plus 1 is equal to e raised to minus 1.8 sin 1.8 divided by 2. That is your yi plus 1. Yi is nothing but your this value, true value. This yi means this only, e raised to minus x at 1.6 only, that is y at 1.6. yi is equal to e raised to minus 1.6 sin 1.6 divided by 2, and delta x we already know. So you know this and delta x. If you plug in this equation, you will find a dy by dx. Any doubt in this? So if you substitute the values, you will get the final value as you have to substitute this one minus this one divided by 0.2. So you will get the final value as minus .0767. This will be your y dash. Okay. So therefore, if you calculate the absolute error, that is, so for calculating absolute error, you will require a true value, right? So that true value is nothing but this. This is your, because you have been given the, sorry, not that is your true value. So to calculate true value, you have to use the second equation, that is this equation. So y dash true is equal to, this is y dash minus 0.0767. So y dash true, if you substitute 1.6 into this, you will get the y dash true, because you are at x is equal to 0.6. So y dash true 1.6 e raised to minus 1.6 half cos x by 2 sin x by 2. So half cos 0.8 minus, right, minus sin 0.8. If you use this equation, you will get to the value as minus 0.0745. So this is your actual derivative value at x is equal to 1.6. This is the value you have got from the forward difference formula at the x is equal to 1.6. So therefore absolute error is equal to 0.0745 plus 0.0767. So this is nothing but 0.0022. This is your using the first question, find numerical derivative using a forward difference formula. Now you will use, then second it has asked you using a central difference formula, and they have asked you to keep h is equal to 0.2 only. So central difference formula. So dy by dx is given by, in central difference you will use the end points, these 2 points, right? So this equation, that is y of I plus 1 minus y of I minus 1 divided by 2 delta x. Y of I plus 1 was, so now we will directly go. So we know how to calculate y is equation I plus 1. Now h is equal to 0.2, right? So I plus 1 means x is equal to 1.6 plus 0.2, that is 1.8, that is x at I plus 1. X at I minus 1 is 1.6 minus 0.2, that is 1.4. So that's what you will put it here. So these x values you will use in this equation of y, this equation of y. So that would be e raised to minus 1.8 sine 0.9 minus e raised to minus 1.4 sine 1.4 divided by 2, 0.7 divided by 2 into delta x, that is 0.2. So if you use this equation, we'll get the value as y dash is equal to minus 0.0734. Okay. Now again we'll calculate the absolute error. Therefore absolute error, we have already calculated the y dash true, right? So that was here minus 0.0745. So absolute error minus 0.0745 plus 0.0734, that is 0.0010. So you can see the error in using a central difference formula was lesser than the forward difference for a h is equal to, for a constant h. So central difference formula will give you a better result, that's what it says. So here your both the question is complete. We also calculated the absolute error and numerical derivative using forward difference, central difference. So what was the question? In the question, first we had given the value of y, this function was given, then its derivatives function was given to you, and you have been told to calculate the value of function value at x is equal to 1.6, first using a forward difference and next using a central difference formula. So you had to use a two different numerical differentiation techniques, and it also asks you to report what are the absolute error in the both the cases. So that's what we have done here. So this was the first question that we wanted to discuss. Now for the second question, repeat the problem in the question 1 using a forward difference formula for h is equal to 0.1, h is equal to 0.05, and report the absolute error in the both the cases. Based on the above result, comment on what is the order of the accuracy. So how you will find the order of the accuracy, that we will discuss later. So what it is telling you, first in the previous question h was given as a 0.2. Now it is telling you solve using forward difference formula only, but first you take a h is equal to 0.1 and next you take a h is equal to 0.05. H is equal to 0.1 and then use a h is equal to 0.05. So how you can, and the last question is what is the order of the accuracy. So order of accuracy is given by, if it's like if step size is decreased by half and the value, absolute error value decreases by factor of 2, then first order accuracy is, or it is also written as OH1. If step size h is decreased by half or a factor of half, and absolute error decreases by factor of 4, implies second order accuracy or OH2. Now we get the idea. If h decreases by half and absolute error decreases by factor of 8, third order accuracy, or it is also represented as OH3. So it's basically asking you what is the order of accuracy and how you can calculate, because now you can, if you have seen the value of h in the previous case was 0.2, now it is asking you to calculate for a 0.1 and 0.5. So it's basically asking you to calculate a very half step, and for each step you will calculate the error and you will compare the error. If the error is also decreasing by factor of 2, then it is a first order accuracy. If it's decreasing by factor of 4, is a second order accuracy, and if it's decreasing by factor of 8 with each step, then it's a third order accuracy. So forward difference formula we'll use in the both the cases. Therefore, h is equal to 0.1. What is the formula? Y dash is equal to yi plus 1 minus yi divided by delta x. Now what is yi plus 1? For this is x is equal to 1.6 plus 1, right? So e raised to minus 1.7 sine 1.7 divided by 2 minus e raised to minus 1.6 sine 0.8 divided by 0.1. Right, this is 1.7 divided by 2. So y dash value is minus 0.0758. This value you get minus 0.0758. Therefore, absolute error is what? How much? Here y dash true is not changed yet, that is minus 0.0745. So minus 0.0745 plus 0.0758 is the value, that is 0.0013. There are some values later also, 51 something, just writing 0.0013. So if you compare in the forward difference, the first error was 0.0022 and it has gone down to 0.0013. So it's when you are reducing the step size by half, your absolute error is reducing also by half factor of 2. So by this you can conclude that you can say that it is a first order accurate. Now we will go ahead, and also there he has asked you to calculate for a 0.05 as well, right? So I guess Ghansham has joined back, so I'll just repeat for you what has happened till now. So in the first case, in the first question we were asked to solve by numerical derivation using a forward difference and then using a central difference, and take h is equal to 0.2 and x is equal to 0.1.6. So what it was asking you to do is, given the function values and its derivative function, is asking you to use a numerical differentiation to get down to the value of a differentiation at 0.1.6 using step size of 0.2. For that, first we use a forward difference and next we use a divided difference, and we calculated the absolute error in both the cases. Now in the second question, what is asking you? First it has asked you that h is equal to 0.2. Now in the second question he is asking you to calculate at h is equal to 0.1 and h is equal to 0.05 and report the absolute error. In this question he is asking you to calculate, he is just asking you to calculate using forward difference only, and he is asking you to calculate. After doing that, comment on what is the order of accuracy. So how to tell what the order of accuracy is? When step size is given by, so when you are we have given some step size and you calculated the absolute error. Now in the next step you reduce the step size by half of it and see what is the absolute error. If it is reducing by a factor of 2, you will say it is a first order accuracy. If it's reducing by factor of 4, you will say the second order accuracy. If it's reducing by factor of 8, you will say it's a third order accuracy. So that's what he has told you to do. So from 0.2, go to the step size of 0.1, that is a half step size, then again a half step size of 0.05 and calculate the absolute error. So what that first part that we have done here. So here we used the same forward difference formula, got down to the y dash value, y true value we had already calculated. From that we calculated the absolute error. So for absolute error, now it is a 0.03 when the step size was reduced to the half size. So first step size was h is equal to 0.2. For that we got absolute error as 0.0022 for forward difference. Okay, we are just focusing on a forward difference now. Now using h is equal to 0.1 and forward difference formula, we got 0.0013. So it's more or less reduced to half of it, right? 0.00222 to 0.0013. So we can say that it is a first order accuracy, but let's go ahead and solve for a 0.05 and see if it's really doing the same way. So now I'll go for a h is equal to 0.05. Okay, h is equal to 0.05 means xi is equal to 1.6, xi plus 1 is equal to 1.6 plus 0.05, that is 1.65. xi minus 1 is equal to 1.6 minus 0.05, that is 1.55. Okay, for forward difference this is not required, only these two values are required, because the forward difference formula is, since forward difference formula y dash is equal to y I plus 1 minus yi divided by delta x. So this will be given by xi plus 1, this will be given by xi. So e raised to I plus 1 is 1.65, 1.65 sin 1.65 divided by 2 minus e raised to minus 1.6 sin 0.8, that is 1.6 divided by 2 divided by delta x. delta x is nothing but h, that is 0.05. So if you calculate this, you will get the value of minus 0.0752. Okay, this would be minus 0.0752. So again we'll calculate the absolute error. Therefore absolute error in this case is, so that is a y true divided by y dash, okay, that you have got. So that is minus 0.0745 plus 0.0752. So if you again calculate this value, it comes out to minus 0.000737. So if you see, it's again a half of this value, right? So as you are, so this value is again a half of this value. So what's happening, as h is reduced by factor of 2, error is also getting reduced by factor of 2. This implies first order accuracy of forward difference formula OH1. Okay, any doubts? Any doubts up till now? Okay, so we'll move on. So this is the first question and the second question. In the third question, what we are doing, we are again going to do the same thing for a h, and h will be same. We'll again go in the half of step size, but rather we'll use a central difference rather than a forward difference. So third question is, repeat the problem question 1 using a central difference formula with the h is equal to 0.1, x is equal to 0.5. Report the absolute error and also comment on what is the order of accuracy. So again, this is how you have to calculate order of accuracy. You will calculate the absolute error for a half step size, and then you will compare how much factor it is getting reduced. It is getting reduced by factor of 2, then it's the first order. If it's getting reduced by factor of 4, it's a second order. If it's getting a factor of 8, it's a third order, and so on. Okay, so in the first question, we had used this central difference formula. So in central difference, you will only use these end points. This is the central difference. Okay. Forward difference means you use these two. Central difference means you use these end points. Okay. So using that one, we had got this value of y dash is equal to this, y true is not changing because it's a true value, and we got this absolute error using a central difference in the first case. Now we will solve it for h is equal to 0.1. So just since it is just a repetition, I will be quick with it. H is equal to 0.1, right? So what is the central difference formula? So y dash is equal to y I plus 1 minus y I minus 1 divided by 2 delta x, right? 2 delta x. Delta x is nothing but this h value. Okay. So e raised to I plus 1 is a 0.1, you will add on a x. So x is equal to xi is equal to 1.6. So I plus 1 is minus 1.7 sine 1.7 divided by 2 minus e raised to minus 1, right? So sine 1.5 divided by 2 divided by 2 into 0.1. So if you calculate the y dash using for this one, you will get the value as a minus 0.0742. Okay. Now you know the y, what is a y dash true, that is minus 0.0745. So you can calculate absolute error. So absolute error is minus 0.0745 plus 0.0742, and this is absolute sign, okay. So what is the value? You will get the error to be 0.000651. In the first case, as h is equal to 0.2, you got the error as, error was 0.0010. So this is going to half of it, right? So it's reducing by fourth order. So if you divide 0010 by divided by 4, you will end up with this value, right? So where was this error I got? In the first question. In the first question, this was the error for a central difference using the h is equal to 0.2. Okay, where h is equal to 0.2, and this was the error. Now we reduced this to 0.1, okay, and we got the error to be minus 0.00651, and we are comparing. This is a this value is a 4 times of this, or this is the divided by 4 value. So because I can say, since when h is reduced by factor of 2, error is getting reduced by factor of 4, central difference formula has second order accuracy, or you can say OH2. You can do it for a 0.05, you'll get the same result. Since it is just a repetition, I am not going to go ahead with that one also. You can do it on your own. If you have any problem, you can mail me or put it on the forum. Any doubt till now? Cool, right? So sorry, this was zero point zero 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 0.0000651. I missed 1 0. I hope this is clear to you how to calculate the order of accuracy. Any doubts? Ghanshyam? Okay, I'll just move on. If you have any doubt, you can post on the Google forum, or you can text me on this chat box. So we'll go now into the 1, 2, 3 this thing, engineering problems, and how to solve it using a numerical differentiations. So this is a problem like cancer cells are seeded in a 35 mm dish which contains a 1.5 milliliters of DMEM high glucose media. So they are trying to doing the cell growth, cancer cell, know how to correct, sorry, trying to know how cancer cell grows. Let's assume 3 into 10 raised to, so it is 10 raised to 5 cells are seeded on a day 0. The following data is obtained by counting the cells on subsequent days. The model, so this is the for a first day, second day, third day, fourth day, fifth day, sixth day. So time periods is 24 hours in between. So H is equal to 24, or you can say delta T. The model for a cell growth versus time is given by this, where kg is the growth rate of a cells. Use central difference formula to compute a dn by dt, followed by computing the value of kg. So in first question it is asking you compute the n dash, that is n dash is nothing but dn by dt at t is equal to 48, using the value of n dash compute the kg. Okay, so you will get the value of n dash, and from this formula, so you will get this value. You will know this value from the table. So n at 48 is 7.8. he is asking you to find the kg. So first thing is use central difference formula to find the value of n dash. So n dash is using a central difference formula. N dash is what? N t plus 1 minus n t minus 1 divided by 2 delta t. So delta t is 24, n t plus 1, so 48, right? So t plus 1 is 72, t minus 1 is 24. So n of 74 minus n of 72 minus n of 24 divided by 2 into 24. So if you substitute those value, you will get n of 72 is what? 12.5. n of 72, so this is n, so this will give you n. So 12.5 and 3.6. 12.5 minus 3.6 divided by 48. So this is 0.1854 in dash. So model, what is the model? Since model is telling you, since from model dn by dt is equal to kg into n. Okay, therefore kg would be, this is n divided by n dn by dt, that is n dash divided by n. So this can be also written as n dash, right? So n dash divided by n, so n dash is 0.1854. So this 0.1854 is for 48. So what is n at 48? 7.8. So that is 7.8. So 1.1854 divided by 7.8, that is 0.0237. So this was us, he is telling you to us what is a kg. So first we calculate the n dash, and using the value of n dash and the time t at the time th, we calculated kg. So kg is telling you the growth rate. So it is a growth rate. Okay, it is, kg is not a mass here, it is a growth rate. So it is a telling you how fast it is changing. So this is the some value which is telling you a growth rate. Okay, now in the second fraction it is telling you to do it for a 72, and third it is telling you to do it for a 96. So we will do that. So t is equal to 72, right? Basically a repetition only. So what it is, you have to calculate n dash using a central difference. So n dash of t plus 1 minus n of t minus 1 divided by 2 delta t. T plus 1 means 72 plus 1 is what? 96, and 72 minus 1 is what? This is 96 and 48. So n of 96 minus n of 48, delta t is constant, so this is divided by 48, right? N of 96 is what? 14.2, n of 48 is 7.8. So 14.2 minus 7.8 divided by 48. Okay. If you calculate its value, it comes out to be 0.1333. This is going constantly increasing. So again we'll calculate a kg. So kg, you have from model, we know kg is equal to n dash upon n. N dash is 0.1333 divided by n. So n at 72. So n at 72 is 12.5. This is 12.5. So this is kg at, I'll just for this sake, I'll completion sake, this is kg at 48. This is n dash at 48, n dash at 72. So n dash at 72. So kg at 72 is, this will be 0.0106. Any doubts? Any doubts up till now? Okay. So the third one, in third one it is asking you to calculate for a 96. So TF for 96. So basically the same thing, n dash is equal to n of t plus 1, n of t minus 1 divided by 2 delta t. So n of t plus 1 is 96 plus 1 is what? 120, and t minus 1 is 72. So n 120 minus n 72 divided by, this will not change, this is 48. So n of 120 is 15.7 minus 12.5. So 15.7 minus 12.5 divided by 48. So therefore n dash is equal to, so what is the value is, quite sure what I have written, so I'll just calculate again. Minus 0.5 divided by 40. So it's 0.06667. So it's going on. Okay. So again from model, this kg is equal to kg at 96 is equal to n dash at 96 divided by n at 96. So this is n dash at 96.0667 divided by n at 96 is what? 14.2, right? 14.2. So this is the value is kg is 4.694 into 10 raised to minus 3. Okay, so this is what we got. So first we have calculated the growth rate kg for at t is equal to 48, that was this one. Then the growth rate at t is equal to 72, that was this one. And the growth rate at t is equal to 96, that is this one given by kg. Now in the last question is asking you, based on above calculated kg values, identify the time interval of the base growth. So basically you have a 3 time intervals from 21 to 48, 48 to 72 and 72 to 96. So these 3 only you calculated. So this 48, it is at 24 to 48 time interval, right? This 72 is 48 to 72 time interval, and this was for 72 to 96 time interval. So what is the best one? Identify the best growth, right? So best growth means the which is the highest value. So the highest value here is this one, right? Sorry, this one. So 24 to 48. So any doubts? We are going to complete 2 more questions and then we are going to done with today's session. So first 3, so this is only central difference, they are divided forward difference we are talking. This is only asked in your quizzes, in your assignment, so I am just focusing on these 2. If you want to discuss any doubts related to 3-point difference or other techniques, I am ready to do that. Just if you suppose, so I am not unnecessarily burdening everyone here, I am just telling you what is required here. If you really have to talk about it, I will talk about it, no issues, just post it in the Google forum. Okay, so if you have seen, for central difference we are using a time step ahead and time step below, right? So what is the case when if the the step size is different in the different cases? So how you will tackle? So if you see in this question, the time size the step size is changing with each one. So here it is 0.52, but after this is a 0.52, but this is not a 0.52, right? In third one, this is not also 0.52, or is it? 7. No, this is not a 0.52. So the step size is changing. So in that case, how to use the central difference formula? That we have not discussed in the class, so I am not going to do that here. You can use it. There is a method. So you will give a divided, so weighted. So in the exams result, you will use a weighted average, right? So you give the weighted average and get the CPI if you have known. So it is just the same way, but I am not going to discuss. I will just use it since it is not mentioned in this question. Just said numerical differentiation, and since the h value is changing, I'm going to use a forward difference, because in that only one step size you require at a one point of time. I'm telling you, you can use this, solve this using a central difference, but I'm going to discuss. If you want, then I will tell you. You post it in the Google form. So you solve. So it is ask you, a jet fighter's position on the aircraft carrier's runway was timed during the landing. So the aircraft is landing on the runway, okay, and its position and is calculated for each time. So it was landing from certain time. So let's say if you saw it the first time from the airport deck, you saw it and you said it is 153 meters away, then you said it is 185 meters away, then it said it is at a 2880 meters away, and so on and so forth. So the distance was distance from the end of the carrier was calculated, and what is asking you, estimate the velocity and acceleration using a numerical differentiation. Oh, I forgot to tell you where. So it is asking you to do it at t is equal to t is equal to 2.37. Okay. So since the time step size is different, I'm using forward difference. Okay, I'm using forward difference. So what is velocity? Velocity is the thing but dx by dt, right? And what is acceleration? Acceleration is dv by dt or d square x by dt. What we will do, we will use a first get the dx. So first we will find the v for, so we want to find a velocity for a 237, right? Velocity for 237 and acceleration for 237. So for that, for calculating velocity, you have x values and you are using a forward difference, so you will require a value at that point and after that point. Similarly, for acceleration also, you will require a velocity at that point, acceleration and velocity after that point. So what we will do, we will calculate velocities at 2.37 and 3.25 and use those values to calculate the value of acceleration at 2.37. Let's see how to do that. So velocity at 2.37 is, using forward difference, what it would be, is it dx by dt, right? So dx by dt is x of t plus 1 minus x of t divided by delta t. T was here, what is a t? T is 2.37. What is delta t? Delta t is 3.25 minus 2.37. So that's what we will write here. So 271. So 270 x at t plus 1. This is t plus 1. 271 minus 261 divided by 3.25 minus 2.37. So this is v at 2.37. You will get value as a 11.36 meter per second. Okay. Now it's asking you in the second question, calculate acceleration at t is equal to 30.37. So to calculate acceleration at this point, you need a velocity at this point, and also at this point. So to get the velocity at this point, we again have to do the similar procedure at 3.25. So you have one more velocity column. So this velocity rows, one value you have got and second value you will get. So velocity at .25. So I'll just tell you is t, x and v. You have 2.37 and 3.25. You have some value of xx. Using this you calculated this. Now you will calculate this. Using this too, you will get the value of acceleration at 2.37 using forward difference. Okay. So first you have to calculate this value. So that's what I am calculating. V at 2.35 is nothing but x of t plus 1, that is minus x of t minus 1 divided by delta t. T plus 1 is nothing but this thing 271, this is x, right? X of t plus 1 is 271 minus 261. So your numerator remains the same. Sorry, this is for a 3.25. So for 3.25, this is t plus 1, this is t minus 1 and this is t. And we are using only forward difference, so this is a x of t. This is x of t, right? So 273 minus 271, 273 minus 271 divided by delta t, that is delta t is 3.83 minus 3.25. 3.83 minus 3.25. So this value would be 3.44 meter per second. So V of 3.25. So now you have T, X, V at 2.37 and 3.25. You had some values and you also got the velocity values. This is 3.44 and this is 11.36. Alright, so these are the values you have already had. So this x is nothing but 261 and 271. This 261, 271. So using these two values, now you can calculate acceleration at 2.37. So acceleration at t is equal to 2.37 using forward difference. Okay, therefore V is equal acceleration at 2.37, that is what, dV by dt, that is V of t plus 1 minus Vt divided by delta t. So V of t plus 1 is this one. So this is your t and this is t plus 1. So 3.44 minus 11.36 divided by delta t is what, 325 minus 2.37, 3.25 2.37. So you will get the value as minus 9 meter per second square. Acceleration at 2.37. So this is going with this is actually giving you a correct result, because this is telling you it is a negative. This is a negative acceleration, that is your plane is retarding. So acceleration is negative means it is retarding, and what we are doing landing in this case. So So in landing, as you go along, the acceleration should reduce. So that's what is happening. So at acceleration at 2.37 is this much. So this is how you can calculate acceleration and velocity using numerical differentiation provided the table. Okay, this can be solved using central difference. Okay, if you have want, then we can discuss some time later. So now we will come to the final question. Any doubts till now? This is the last question. So if you have any doubts, you can, in this last question, if you have, do you want me to repeat? This is just straightforward. You have given the x distance values, you know how velocity is just the dx by dt. So we calculated for forward difference you require a velocity, your velocity position of ahead value, and that value, using that we calculated the velocity at that point. So velocity at 2.37 was already done. Then in the second part, the question asks you to solve the acceleration. Now for acceleration, you needed a velocity at the next point as well. So we calculated first the velocity at the next point, and then using those values, we calculated the acceleration, again using the forward differentiation formula. So it's pretty straightforward, using the same formula again and again. You just know how to use it. So again, this is question using a numerical differentiation. Now if you see the x value, the delta x is constant, so delta x or h is 0.08. So in this case I am going to use a central difference, because I know central difference is giving me a less accuracy, higher accuracy and less error. So it's a second order accuracy and a higher, less error. So when you have a choice, you can use it, right? So it is not mentioned anywhere to use a central difference, that I am going to use a central difference for this one. So what is the question? The heat flux Q is the quantity of a heat flowing through the unit area of a material per unit time, and it can be computed using a Fourier's law. J is equal to minus K dt by dx, where J is a unit of watt per meter square, K is a coefficient of thermal conductivity that parameterizes the heat conducting properties of the material, and as unit of watt per degree centigrade meter. T is a temperature in degree centigrade, x is a distance in meter along the path of the heat flow. Following temperatures are measured from x0 into the stone wall. If the flux is this, flux at x is equal to 0.08 is equal to this, compute the x, this is meter square. Okay. So what it is telling you, so the heat flowing inside the wall is given, heat flow through the wall is given by a Fourier's law, and the Fourier's law is given by J is equal to minus K dt by dx. Okay, where J at 0.08 is given to you 60 watt per meter square. That is what it is telling you. Okay, and is asking you to compute K. So you know this value, you want to find this value. So what remains? You have to find this value. So we have to first find dt by dx, but not at any value. Since J is given at 0.08, this will you also calculate at 0.08. So this is what, when you have these two values, using this equation you can calculate the K. That is what is asked. Where it is asked, compute K. Okay, so compute K is using this equation. So dt by dx is nothing but the first derivative, and since the h value is constant here, the step size is constant, I am going to use central difference formula. So therefore using central difference formula, Now what is central difference? We have to find out t dash. This is dt by dx. That is t at x plus 1, or I can say better way, I plus 1 minus t at I divided by delta x, right? So delta x is what? H. So that is 0.08. Ti plus 1, this is Ti plus 1, sorry, yeah, this is I plus 1, I minus 1, and the Ti plus 1 is 15 and Ti is 70. So 15 minus 70. Right? So what is the value? 15 minus 17 divided by 0.08. But if you see, you can't use 0.08 directly, right? This is in centimeter and these all are in meters. So this would be, oh sorry, I'm going to use central difference, right? Oh sorry, I was going to use using central difference. So the formula would be Ti plus 1, Ti minus 1 divided by 2 delta x. So I told you I'm going to use central difference, and mistakenly I used forward difference because I was using for a long time in the previous questions. So in central difference, it is end points divided by the whole distance. So from these 2 points we'll use, so and this distance, right? So this is what Ti plus 1 is 15 minus Ti minus 1 is 20 divided by 2 delta x, 2 into delta x, but delta x is 0.008 centimeter, right? 0.08 centimeter. So if you convert it into meter, this is 0.0008 meters, right? So 0.0008. Understood? So 15 minus 20 divided by 0.0016. If you calculate this, you will get t dash as, or a dt by dx as minus 3125 degrees centigrade per meter. Okay, so this is your, using a central difference formula, this is dt by dx minus 3125 degree centigrade per meter. So now you have a j at 0.08 and dt by dx at 0.08. You just want to find a k. So therefore, using Fourier's law, k would be minus j divided by dt divided by dx, right? So k divided by dt divided by minus, so minus sign is there. So minus, it would come as, what's happening, minus, what is the value, 60 divided by minus 3125. So therefore k is equal to 0.0192 watt per degree centigrade meter. So this c should be capital and then small. this is how you calculate K. Here I use the central difference formula. You as well can use a forward difference, no issues with that. But in central difference, you will get a more accurate answer. If you have a choice, then you can use a central difference. So this was what I wanted to discuss related to numerical differentiation. I have focused on a central difference and forward difference, when to use, how to use, what, how to find the order of accuracy, and the questions related to it. When the step size is similar, you can use you can still use a central difference formula. I have not discussed it because it was not discussed into the class. So if you want me to do that, I will do that, no worries, but just post me the questions, or you can Google it yourself, you will get it. It is not that easy, it's just a weighted difference you have to do. So this is how you will solve. This might be the way the question paper might be there in the exam. So if you have any doubts in this, just post it now. You can ask me, otherwise we will wind up the session. Any doubts? Ghanesham, any doubts? Okay, I hope you are following me along. If you have any doubts, if I'm going any fast way, just let me know. I'll be slower. But do you want me to repeat anywhere? Okay, so I think we'll conclude these sessions. Thank you for listening. If you have any doubts related to the questions discussed or in the quiz, just post it on our Google forum. Yeah, thanks for listening to me. And if you still have any doubts, just post it. We will try to address it in the next session. So next session will be on our regular times on Tuesday 7 to 9. Next Tuesday 7 to 9. So meet you then. Good night. Take care.